Hi guys, good afternoon. So in the last session, we went with the packet types and the neighbor table. Today we'll go with the EIGRP topology. Okay. Now if we talk about topology table, so what do you know about the EIGRP topology table? What do you know about the EIGRP topology table? About routes? What routes? Hmm? So EIGRP topology table contains both your best route and the backup routes. It contains both the best route and the backup routes. Okay, so that's why we say that this is a list of all, like this contains a list of all the routes. Okay, so in other words, we can say the EIGRP topology table contains the successors and visible successors. Contains the successors and visible successors. This is clear. Now, what is a successor here? So if we talk about successor, so about successor, you can say it is the best route, and this one is available in both routing table and topology table. This will be available in both the places, in your routing table also, in your topology table also. Then if we talk about visible successor, so you can say that it is the second best route. Okay, it is available only in the topology table. So this one is only available inside the topology table. Okay. This is clear. How do you check the topology table? Show IP IGRP topology. So we can say we can check the topology table using the command show IP IGRP topology. Okay, not scroll the last. Okay, so we have some configuration for R1 and R2. So we'll use the same lab. Okay, this time I don't need the secondary addresses. The rest of everything is okay. Allow it to come up. Going to do the configuration for topology table, right? Just for the okay. This is the topology for topology table. I'll wipe all the notes. Start all notes. These are the network IDs. Who will configure this lab? Who wants to do it? Nobody says. Mhm. Right? Yes, we'll do it quick. Yeah. Anybody else? No, you can do it. You did, I think yesterday you did. No? Okay, start. Oh, you start then. Three, six routers are there, right? Six or five? Five. You do two, you do three. R1, R2, then R3, R4, R5. You just do it quick. Take the mouse if you need to copy paste. Check on R1 also about no shit. R1. G0 by 1. But R3, R4, R5. Just take it to the right. Take your mouse to the right. Yeah. If you need to copy paste, you can copy paste. Put an exclamation before the name. R1. Also on the output. Change it to output. Sample command is commented. All good. So 13, 25, 13 and 34. 34 and 45. It's 25 and 45. Okay, everything looks good. Let's take an axis, R1, R2, R3, R4, R5. This is R1. R2. R3. R4. R5. R5 IP address mistake.
Sir, it's in R2 as well as R3 and R4 as well.
Okay. Also in R2, R3, R5. Multiple zeros. This is R4. Okay. All right, then we should have two adjacencies everywhere. We have two, two, two. Here also. All right. The text is visible, or I need to keep it dark, the background? Visible to everyone? Okay. So let's check. Do show IP EIGRP topology, right? So what do we see here? We see a code, right? This is P. Another code is active. So what are these? Hmm? Active and passive. What are these things? Hmm? Sorry. In a simple way, if you want to define it, you will say these are the route states. These are what? Route states. So two route states we have. Number one, passive. Number two, we have active. If the state is passive, which is by default, it means the route is reachable. It means the route is reachable. That means you are able to reach the route. And a route will be put to the active state if a successor or feasible successor goes down. That means the route is not reachable. Okay. A route in the topology table will be put to the active state if it is not reachable. If it is not reachable. Okay. And when I say not reachable, that means the successor and feasible successor is down. successor and visible successor is down or they fail. In that case, a route will be put to the active state. This is clear. Okay. Now, here we have to understand a concept. Here we have to understand a concept. The concept of visible distance and advertised distance. Okay. So kind of we have two types of distances. Okay. So if we take a look here at this output, okay. So let's take example of this route itself. This is how you'll see a route. Correct. Now, P means this is the state. This is what you see here. This is state of route. So right now P stands for passive. Then how many successors are there? Only one successors are there. Okay. Then here it is telling you about the visible distance. This is what? Visible distance. This one, as well as it will also be displayed here. So both of these things are what? These are the visible distance. This is clear. Then we have this one here. So let's say, so this one here, this is what? This is the advertised distance, also known as reported distance, AD or RD. This is clear. Now, what is a visible distance? Hmm? This is also metric only. Hmm? Sorry. Mhm. Now see here. Here it was explained about your FD and RD. See here. Visible distance. This is the integer metric for the route from the local router's perspective. This is used by the local router to choose the best route for that purpose. And what is RD? Integer metric for the route from the neighbor router's perspective. Okay, so the neighbor that told the local router about that route. So this is used by the local router when converging to a new route. That means when deciding a new route. Okay. And also you must know that some of the textbook, they use the term advertised distance instead of the reported distance. Is that clear? Okay. So that means we can say that the least metric, the route with the least metric or the least metric is known as what? Visible distance. Okay. So we will say about visible distance in the visible distance of a route is the least matrix. Okay, this is the least matrix. Or the route with the least matrix is known as the successor. And the least matrix is what? Your visible distance. What is reported distance? The distance advertised to the local router by the neighbor is known as the reported or advertised distance. This is clear? Yes or no? Okay. Now, consider like we have two routers. Okay, like this we have two routers. Okay. Say this is R1, R2, R3, R4. And this side we have a network. To reach that network, we have the distance 5 and these all distance, let's say 10. So to this router, to reach the network, what is the FD here? FD equals to 5. So this router R4, what is the FD? 5. R3 to R4, the distance is 10. So when R4 will advertise it, so R4 will advertise what? Its own FD. And this FD will become here what? RD. So R4 will say that, okay, from my place, the distance is what? 5. So how R3 will calculate? R3 will calculate that, okay, I need to calculate the FD here. And my FD will be what? My distance to R4 plus the reported distance. That is 5. So which is overall 15. This is how this guy will calculate. Clear? Now to this guy, the FD is what? 15. Okay. So this guy will advertise what? That okay, from my place, the distance is 15. So this guy will say my distance is 15. So this guy will calculate that okay, my FD will be my distance to R3 plus R3 is telling that from there the distance is 15. So overall 25. And then this guy will advertise that okay, from my place the distance is 25. So this guy will calculate that okay, I will calculate FD how that I can reach to you via 10 and you are telling me distance 25. So this is the total distance. So that means FD of neighbor becomes RD. Simple. FD of the neighbor becomes RD. That becomes the reported distance. Okay. This thing is clear. Now, When there are more than one routes available, more than one possible route is available, in that case, what happens? Feasible successor will be there. But to become a feasible successor, there is a condition. A route will by default not become a feasible successor. Like in this case, if you see, if you check here, now we have two possible paths. We have two possible paths. Yes or no? But if you take a look, do I have two routes for the, let's say, 5.5.5.5? Okay, I think we didn't advertise 5.5. Let's go to R5. Did we create loopback here? No. Okay. Now I should see a route on the. So if I check, do show IP route EIGRP. So I can see I have a route for 5.5.5.5. How many paths I have? Two possible paths. So if I check the topology table, show IP EIGRP topology. So for 5.5, you see I have only one successor. I don't see any feasible successor here. I don't see any feasible successor here. That means I don't see a backup route here. Is that clear? Okay. And here we have two which are having the same metric. So here what is happening? The load balancing is happening. You can see for 45.0. Because when from R1, you want to go to this network. So through this side also I have two routers. Through this side also I have two routers. So the load balancing will be there. Correct? But why I don't have the feasible successor for this network? All right. So there is a condition to become a feasible successor. There is a condition to become a feasible successor. That condition is known as feasibility condition. So note down that condition. To become a route can become a feasible successor only if it satisfies the feasibility condition. Only if it satisfies the feasibility condition. Now, what is the feasibility condition? Hmm? Correct. Okay. Feasibility condition. So what is the feasibility condition? The reported distance of the route should be less than, not even equal to, should be less than the current FT. Whatever the current FT is there, the RD should be less than that. Okay. So in short, I'll say feasibility condition equals to RD of route should be less than current FD. This is our feasibility condition. Okay. And this is the feasibility condition. This is clear. Now, how do we know? How do we know that, okay, what is the particular RD of the route? Let's say from R1, right now I'm having this as the best route. But how do I know that, okay, what is the RD for this route, for this part? How can I check that? Hmm? Now, one thing I can do is I can go and shut down this interface itself. If I will shut down this interface, all the routes which are being learned via this interface will be down. So let's see. I'll go to the R1 in interface gig 0/0. So what is the current FD first of all? For 5.5, the current FD is 131072. This is the current FD. Okay. This is the current FD. We got to know 131072. Okay. Now I'll go to the interface Z 0/0, shut down. So this interface will be down, right? And then I can say do show IP EIGRP topology. So you can see now this is going via 13.3, 13.3 path, right? Second path. Let's see here. This is the second path. Okay. Now check what is the RD. And what is the current FD? So what is happening? They are FD and RD same, right? FD and RD is same. So now what to do? So what should we do? The condition is your RD should be less. RD should be less. Now, how do I make the RD as less? Think about it. How do I reduce the RD? Because right now this is equals. And like I said, feasibility condition says it must be less. It should not even be equal also. It should be less than the FD. So now what to do? Hmm? What should we do? change the matrix. How? Yes. Which interface bandwidth should I change? Okay, tell me one thing. Here, where should I change the bandwidth? Which router, which interface? R1. What is the condition? RD should be less. So R1 has no role in the RD. Either it has to be R3 or R4 or R5 itself. But again, which interface of R3? Z0 by 0 or 0 by 1? Which interface of R4? 0 by 0 or 0 by 1? Which one should I alter? Z0 by 1. 5. Why not Z0 by 0? It is taking this one bandwidth. Now, another question. I should increase the bandwidth or decrease the bandwidth? Hmm? Hmm? Now, for this thing, we need to go with the metric, right? We need to understand the first of all metric. We need to understand the. Hmm? Like I said, that somehow we have to understand what metric formula. Then only we will be able to decide that whether to increase it or to decrease it. Correct? Okay. So let's go with the metric formula. Matrices. Yeah, this is not properly. See, this is the formula here. This is the formula, right? Note it down. EIGRP for metric formula. This is the metric formula. Note it. Now, the question here to you is, what are the default key values? K1 equals to 1, K2 equals to, K3 equals to, K4 equals to, K5 equals to. Put these values in the formula and calculate the value. Put these values. Hmm? Enter the first 7 by reach bandwidth plus delay 20%. Is it? Check again. Or you're forgetting maths. Hmm? Is it? Because you have crammed the formula. Hmm? Tell me. Zero. Why? Because K5 is zero. And anything you multiply with zero, entire bandwidth itself, entire term metric itself is zero. Then what to do? How come the formula is something else? Hmm? Or you can say 0 divided by anything, infinity. Then what happens? Now the people who are saying 10 raised to power 7 upon bandwidth and all, what happened? Hmm? According to mathematics, what should happen? Man, the metric should be, that means EIGRP should not have any metric. Same like connected route. Or static route is also having what? Metric as 0 only. Then what is happening here? See here, let's say if I open your book, uh, this will be there in the NRC. EIGRP metric calculation. This is the metric formula, right? See here. Now tell me what is this calculation? According to the values, these are the values. Yes or no? That K1 1, K2 0, K3 1, K4 0, K5 0. Then how come this value is there? In the interview, if somebody will ask you, then what we are going to say? We don't know. We just say, okay, in the book like this, then we also go like this. See here. RFC 7868 states that if K phi equals to 0, then the reliability quotient is defined to be 1. Okay. The reliability quotient defined to is to be 1. This does not this is not demonstrated in the figure 2.7, but it is shown in the simpler formula in figure. Like you can simply understand in a simple manner, you can understand that okay, if K phi is 0, this part should be considered 1. This part should be considered 1. Now, if you consider this one as 1, then after your calculations are all good. Then after your calculations are all good. Is that clear? So this note is important. That means basically what is happening, that whatever the values are 0, you simply consider that, okay, this part is 1. That's this part is 1, this part is 1, then you will have your correct formula, which is this one. That means if these values are 0, so do not make them 0 or infinity. That means we are not including or using these parts. As simple as that. That means out of the formula, I'm not using this and I'm not using this. Clear? So just you can say according to RFC 7868. That is enough answer. According to RFC 7868. That's it. Now, if somebody needs to know, they can refer to RFC 7868. Is that clear? There it is shown in very much detail. This is clear. Now we got a formula something like 10 raised to power 7 upon minimum bandwidth plus total delay by 10. So whatever the total delay is there, divided by 10. There. Okay. This is clear. Now let's say you have a gigabit Ethernet port. So that means your link speed is what? This. Your link speed is this, and delay is 10 microsecond. Correct? So what will be your metric? 2816. Now you'll say how this is the case. So you have written this formula, right? 10 raised to power 7 upon minimum bandwidth. Okay. So if I say 10 raised to power 7, like if I say 256 multiply 10 raised to power 6, sorry, 10 raised to power 7. Okay. And this is divided by bandwidth. What is my bandwidth here? Like if you check in the book, for a gigabit, 10 raised to power 6, and delay will be 10 by default. So put the values. This is 10 raised to power 6. Then here plus we have, okay, and here we have a bracket. Okay, this is a bracket. And then what do we have? We have 10 divided by, this is the total delay, divide by 10, right? So if you calculate this value, this will be what? 256 multiply by 10 plus 1, if I'm not wrong, which is 256 multiply 11. What will be the value? You can use your mobile phones.
2816.
2816. This is the metric. So you can verify what is the metric here. So this is how the metric are being calculated. Clear? Okay. So now we have to change the metric. Now we got to know that either we can change the delay, either we can change the bandwidth. Now, if I increase the bandwidth, this value will be lower. But if I have to change something, let's say delay, so that means I'll have to change this value. I'll have to change this value. Now, already my delay is in microseconds. So that means if I will give value 1, then my router will consider that, okay, this is what 10 microsecond. And less than 1 value, we cannot give. Value less than 1, we cannot give. That means what we should do? As of now, we should change what? Bandwidth. Okay. So let's say if I want to change the bandwidth to reduce the total value, should I increase the bandwidth or decrease the bandwidth? Remember, I need to lower the RD. That means entire value, I have to lower it. That means I have to increase the bandwidth. Right now it is 10 raised to power 6. Okay. So according to 10 raised to power 6, the value is this. Correct? Let's see. So if I go on R3 and let's say I will use this one. I will use this one here. I'll try to change Z0 by 1 on the R3. First of all, enable configuration terminal. Do show interface Z0 by 1. And if I take a look, 10 raised to power 6 kilobit. Okay. Interface Z0 by 1. Bandwidth. And you can see I can give it until 10 kilobits, that is 10 raised to power 7. Okay. Let's say I'll give only this much. Very slight increase. So if I check bandwidth change, let's go and check the metric on R1. Show IP EIGRP topology. What do I see? Through 13.3, still my metric is what? Same. Why? Why this metric is same? Hmm? Why this metric is same? Yes. Louder, please. Increase delay. Increase or decrease, first of all? Increase. Shall I increase or decrease? Hmm? Decrease. Decrease or increase? My goal is my RD should be less. That's it. We should increase the bandwidth. Okay. So how much? I already increased by 500. Okay. Let's say I'll make it 10 raised to power 7 then. I'll change it to 10 gigs. Now, okay. You can see how many zeros I have. Okay, here I am. How many I gave? 6 only I gave. Okay, let's increase. Now, 7. Still same. Now, what should I do? Am I changing wrong interface? Hmm? Delay. What should I do with the delay? Decrease or increase? Decrease. So, what is my current delay here if I check? If I check, what is my delay? 10 microseconds. Okay, so how much should I make it? Hmm? How much should I make it? How much should I decrease? Hmm? Tell me. Hmm? Shall I make it 100? If I'll make it 100, 100 by 10, the value will increase. It will not decrease. It's already minimum value. Correct. Because if I will say 1, it will make it 10 because it is in the tens of microseconds. So what to do? Hmm? Okay, is it? See here. In the formula, if you see, what is mentioned here? So on the link, it will check what? It will check minimum bandwidth. How the metric is calculated is, see, on this entire link, on this entire link, whatever the minimum bandwidth is there, that will be taken. Then delay will be added. All delays from here, 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 and here. All the delay will be added. Bandwidth is which link is having the minimum bandwidth. So let's say I changed it here. The bandwidth I changed here. I will also change on this interface. So this link bandwidth will be like both sides I will increase slightly. Okay, so if I go on R4 and if I increase on Z 0 by 0, let's see if it makes a difference. Okay. Enable configuration coming out. Then I'll say interface gig 0/0. Okay. Bandwidth, let's say this side, I'll say something like okay. Then let's see if it makes any changes here. still the same between R4 Z0 by 0 and R3 Z0 by 1. Done. Do you see the change? You can see the change. So what is happening here? It is taking minimum bandwidth. So that means now if I need to increase the bandwidth, so I'll increase for both of them. So let's say it was what? 10 raised to the power 6. This was the bandwidth. So let's make it like this. Slight change. And same thing here. Now let's check. Is it going lower or not? What is happening? Okay. So here what is going on? This is changing. Earlier we were able to increase it. So when I increase the bandwidth, why it is not taking? Because again, it is taking the lower bandwidth. So instead of trying to change here, why don't I change a little bit here between R2 and R5? So if I'll try to reduce the bandwidth here, metric will little bit increase. Metric will slightly increase. So let's see. So here we will set it back to default, whatever the configuration was there. So no bandwidth. And here also no bandwidth. Back to default. This time we will change between R2, R5. Okay. And now let me no shut down the interface also of R1 because we already have both the values. Interface gig 0/0. Not shut down. Done. Okay. So right now, if I check, do show IP EIGRP topology. So we can see that this is the best metric. Okay, again, it is going here. Wait for it. Okay. So we can see this is the metric and this is the RD. So I'll increase this RD little bit so that my metric will also little bit increase. So this is Z0 by 1 interface. This is Z0 by 0 interface. Enable configuration terminal. Interface gig 0/0. If I change the bandwidth here and on R5 Z0 by 0, bandwidth, that was Z0 by 0 or 1. Okay, I changed the wrong interface. Z0 by 1 and this one. Now let's check. So RD has changed here, but FT did not change. And, FT, we have to this one. Okay, between R1, R2 also I'll change here, Z0 by 0. Interface gig 0/0. Bandwidth. The value. Okay. Sorry, my mistake. R3 and R4 we changed it. Okay, let's change it. But if I will increase the bandwidth, and just pass 7 upon minimum bandwidth. So let's go with this bandwidth here. Here also, this one. Same thing here. And R1 also the same. Now let's check. Wait for it. R2 Z0 by 0 is changed. Now it will change. Both. Between R1 Z0 by 0 and R2 Z0 by 0 we have changed, and here also we have changed, right? Between R2 here, yeah, here. This side I don't need to change. R3, R4 we are not changing. Now if I check, see, now both are successor. Okay. How come both are successor? How they can have the same metric? Okay, what is the bandwidth of loopback interface bandwidth? Z0 by 0. To show interface. This is the least bandwidth, right? So let's change it. How? This is strange. This one is using default. Let me try this also. See, right now we are going blindly. So what we'll have to do, we'll have to calculate the metric like carefully. First of all, delay calculation, then metric bandwidth calculation. Then accordingly we will have to calculate. And then we can decide that what we have to change. Right now, we are just shooting blind. So right now, I'll just remove all this bandwidth configurations from the interface. Here we don't need that. Here we don't need. From here it is removed. This is done. We can also remove. Do show running interface v0 by 0. Nothing. v0 by 1. Nothing. Do back 1. Okay, this is fine. Do show running interface v0 by 0. Here also no configuration. 0 by 0. v0 by 1. All good. This is also okay. This is fine. This is also okay. So right now everything is back to default. And this is what we are having, right? So now we'll calculate that why this metric is 13107. Okay. We'll show running interface, low back 1. We'll show interface, low back 1. So see, this is, note down this. And also note down the delay. These two things. This is for the loopback interface. This practically you will be able to see if you have the routers with fast Ethernet interfaces, because there you can easily play around with the fast Ethernet interfaces. Now that so, see, if you have a fast Ethernet interface, right? So your delay is 1000 microseconds. So we can play around, like we can reduce it and we can increase it. So there it will be easy. But in gigabit, we all are like in gigabit, we already have the minimum delay. So we cannot change the delay. We have an option to play with the bandwidth only. Okay. So that makes it difficult. But still it's okay. Right. Note it. Okay. Then here delay is 10. Here delay is 10. And bandwidth is 10 raised to the power 6. Okay. Note down. So our minimum bandwidth, I guess, in this case also, because that is 8 into 10 raised to the power 6. And this is only 10 raised to the power 6. So 10 raised to the power 6 is the minimum bandwidth, right? That means this part will remain 10 only. Which part is changing? This one. So we have, let's say through the best route, we have 5000 delay plus we have 20, 10 and 10, right? So this will be 5020. If you divide it with 10, 502, and then you will add here 10. This will be 512. And if you multiply it with 256, check the value. 512 multiplied 256. Are we getting the same value? Hmm? 131072, right?
Yes,
Okay.
sir.
Now, second case. This case we have 50 delay, sorry, 5000 plus 30 in the delay, right? So this time we are having 50, 30 divided by 10. This is what? 503. So this is becoming 513. 513 multiplied by 256. So if you add 256 here, so this will be, I think, 328, correct. 131328. This is the value. Now here we don't have an option to change because if I will change for this one, right? So that will affect both of them. And again, eventually we will get the similar kind of value. So here we don't have an option. So this thing will be possible only with fast Ethernet interface routers. Like you can do it in GNS3. In GNS3, you can get routers. Or I think those images, let me check if I have. No, these images. I think I have. But again, the same 15 dot something I have. So this practical where you can do, you can easily do it in either packet tracer you can try or GNS3. With the fast Ethernet interfaces, it will be easily done. Okay. But you got the idea. We can play around. So bandwidth is not really a good option to play with. Better option is delay. Okay. All right. Now, if you have more than, let's say, for example, right now, what is happening that we don't have a successor as of now. So without successor, we cannot go with the variance concept also. Okay. So if I will go with a direct link, in that case, to just calculate one more value. That if I use a direct link, in that case, we will have 5000 delay plus 10 delay. So in that case, this will be what, 510? So 510 multiply by, sorry, 501, 501. This will be 5010, and if we divide it by 10, this will become 501. If you multiply it with 256, this will be 128,256. This will be the value for the direct link. And one last value, which is multiply 500 with 256. That will be the RD. 128. And less than this, so we cannot have it anyhow. No, with this it. So if I will make the delay of the loopback interface also 10, so it will change everywhere, right? And these values will come in the same difference. So with gigabit, we cannot do this practical. Only with fast Ethernet, you will be able to do it. Because in fast Ethernet, we will get a gap of 1 to 10 at least. 10 values gap we are getting. That is the reason. Because this is the minimum value we can set. Beyond this, we cannot do. Okay, but you got the idea, right? Okay. So to become a feasible successor, you see right now our feasibility condition did not met. So the route did not become a feasible successor. So to become a feasible successor, it is very important that your feasibility condition should be satisfied. Okay. All right. Then let's say you have a feasible successor also. You have a successor as well as a feasible successor. But we know that in the routing table, what will be available? Only successor. Feasible successor will not be available in the routing table. So if you want that, okay, you want to use more than one path. That means we know that EIGRP performs what? Equal cost load balancing. EIGRP performs equal cost load balancing. We know that. But EIGRP can also perform unequal cost load balancing. That means we can put the successor and the feasible successor, both of them in the routing table. But how? And for that, we have to use the concept of variance. We have to use the concept of variance. But again, to see the variance practical, I think we'll have to design one lab with the older operating system and fast Ethernet interfaces. So I'll put the router's image and then tomorrow we can do it. Tomorrow is Friday, right? I was hoping we will complete EIGRP this week. Let's see, maybe Monday we'll complete EIGRP. Okay, so you guys check today about variance. Okay, check about variance, and after the variance, check about leak map summarization. I mean. This is task summarization, variance and summarization. Check about these things. Okay. Online people, clear so far? Okay, one more question. That right now we have this lab right here. We have this lab. So when I'm saying delay, so right now the both the sides, metric and the bandwidth and delay both are same. So we can consider any one. But actually, EIGRP is considering which delay, this interface delay or this interface delay, that you have to check. That means, is it checking exit interface delay or is it checking neighbors delay? Which delay is being checked to calculate the metric? This is you have to research. 0 by 1. Check it. And if you get a proof, send in the group. Okay. All right. Okay, guys, then I'll see you tomorrow. Have a good day.